Hi everyone, let us see about the delta modulation and its principles. Delta modulation is called a 1-bit or a 2-level quantizer version of DPCM. It provides a staircase approximation to the oversampled version of an input. It's an important statement to be remembered. Delta modulation provides a staircase approximation to the input baseband signal oversampled version of the staircase approximation. The difference between the input and the approximation is quantized into only two levels, namely plus delta or minus delta. Plus delta corresponds to positive and minus delta corresponds to negative differences. The approximation falls below the signal at any sampling EPOCH, it is increased by plus delta. On the other hand, if the approximation lies above the signal, then it is diminished by delta, plus delta or minus delta. I have shown you a red color graph curve taken from the textbook. That curves is called x of t, and it is the input signal to be quantized and encoded using delta modulation, whereas the staircase approximation, which is shown in blue color, is called the approximation to the input, right? Staircase approximation remains within plus delta or minus delta, plus delta or minus delta. Such a miraculous encoding procedure which corresponds to positive or negative differences, right? The approximation falls above, lies above the signal, it is diminished by delta. If the approximation falls below the signal at any sampling instant, then it is increased by delta. In fact, delta denotes the absolute values. ABS value of two representation levels of the 1-bit quantizer, whereas delta levels are indicated by the graph which is shown at the bottom. In fact, what is delta? Delta is actually indicated in the transfer characteristics. This is called, let me call this as transfer characteristics. Transfer characteristics. The step size is called step size in delta modulation is equal to 2 into delta. This is very, very important and to be remembered forever. They may ask you in the Viva questions. Okay. So let me move on to the modulator part. You can notice that E of x of NTS is the input signal. Let me call this as a oversampled input signal, to which x cap of NTS, the latest approximation to the input, is also available. The difference is generated, that is called E of NTS. The E of NTS is passed through a 1-bit quantizer or 2 representation level quantizer, and then it produces an output as B of NTS. B of NTS is actually looped inside the transmitter itself, where the B of NTS is added with x cap of NTS. What is x cap of NTS? From the diagram it is evident that x cap of NTS is U of NTS minus TS, delayed version of U of NTS. So U of NTS is simply B of NTS and x cap of NTS. Okay. What is x of TS? X of T? It is called the input signal. What is U of T? Staircase approximation, latest staircase approximation to the input signal. What is E of NTS? E of NTS is x of NTS minus x cap of NTS, where x of NTS is minus U of T NTS minus TS, because x cap of NTS, from the diagram it is very understood, it is easily understood. X cap of NTS is equal to U of NTS minus TS. You can notice it. That's what we have done, a simple replacement. And B of NTS is delta multiplied by SGN of E of NTS. So U of NTS will be equal to U of NTS minus TS plus B of NTS, right? What is TS? TS is called a sampling period. What is E? E of NTS is called error, prediction between the present sample value and the latest approximation to it. X of NTS and x cap of NTS. X cap of NTS is U of NTS minus TS. That's the because you can notice x cap of NTS, right, is generated இப்படி தான் போகுது. Just notice it. Where Ts is the sampling interval. Okay. So what is B of NTS? B of NTS is the 1-bit word transmitted from delta modulation. Okay. What is B of NTS? B of NTS is a 1-bit word naturally transmitted out of delta modulation. What is B of NTS? B of NTS is the algebraic sign of E of NTS. What is E of NTS? E of NTS is the difference between original and the predicted value, or the latest approximation to it. Except the scaling factor, B of NTS simply gives you only the algebraic sign. More importantly, P of B of NTS is equal to del multiplied by SGN of E of NTS. 1-bit code word is transmitted by delta modulation. So from the diagram we could understand that the modulator or a transmitter comprises of 2 summing units, 2 level quantizer and an accumulator. So accumulator is actually U of NTS is equal to delta multiplied by I varies from 1 to M or N SGN of E of NTS, so which can be modified into summation B of ITS, right? Super. At each sampling interval, the accumulator increments the approximation to the input signal by plus delta, depending on the binary output to the modulator. So how does the receiver work? It's so simple. We have to pass the incoming sequence of positive or negative pulses through the accumulator. It looks similar to that of the transmitter side accumulator. So we will always pass, what is it? What is the input to it? The input will be, let me say this is the input, and both of them are going to be added together and it's going to produce an output. What is the input to the receiver? So the positive or negative pulses, the incoming sequence of positive or negative pulses are passed through an accumulator in a manner similar to that of the transmitter. So the out of band quantization noise in the high frequency staircase waveform can be removed by the low pass filter. Out of band quantization noise in the high frequency staircase approximation waveform is rejected by passing it through a low pass filter, whose bandwidth will be normally equal to that of original signal bandwidth. Okay. So when you want to make a comparison between DPCM and delta modulation, there is always a point. Delta modulation is a special case of DPCM and it contains a 1-bit code word for the output, and in fact it has got a salient feature of having a simple design for the transmitter and receiver. That's how delta modulation is discussed. Thank you so much. See you then.